I welcome you all for the third phase of AICT sponsored short term training program on electrical vehicle technology. On behalf of our management, principal, head of the department, and faculty members of Department of Electrical and Electronics Engineering, Panimalar Institute of Technology, I welcome you all for this session. Today we are having the eminent speaker, Professor Dr. Mohanty, Professor, the Department of Electrical and Electronics Engineering, Sri Venkateswara College of Engineering, Chennai. He did his M.Tech in Vishweshwara Technology University, Belgaum, Karnataka, and PhD in Anna University, Chennai, on power electronics and drives. He has a huge experience in teaching as well as research. His teaching and research experience is around 16 years, and his research interests are in power electronics and drives. He did research in converters, inverters, DC-DC converter, AC drives, DC drives, and control. And in power system, he did his research in power quality improvement, FACS, HVDC. And in energy system, he did his research in renewable energy systems, and he published around 16 papers in the international journals. He is the PhD supervisor of Anna University Chennai and presently guiding 9 PhD students. With this few words of introduction, I welcome Professor Dr. Mohanty sir, and I'm handing over the session to sir. Please, sir.
Thanks, sir. Thanks for your introducing me and to present before all the staffs in your STTP program. And thanks, sir. You have invited me and given me opportunity to deliver um, the topic that is SRM, that is switch reluctance motor application to electric vehicles. Thanks, sir. And can I share it? Can I share this PPT, sir? Hello?
Yes, sir.
Yes, sir. Is it sharing? Is it sharing, sir?
Sir, now it is sharing, sir.
Okay. Is it okay, sir? Comfortable?
Yeah, it's fine, sir. Fine, sir.
Okay, okay, sir. Okay.
Yeah, yes.
Thanks to
Thank
all.
you.
And today I am going to uh, uh, I am going to present before you the topic that is the switch reluctance motor application to electrical vehicles. Everybody knows what is electrical vehicles, why we are going for electrical vehicles, and I don't want to go that things, and why we are going to switch to electrical vehicles, why so many papers are coming on electrical vehicles, and everybody knows. So I don't want to present that things. I will go for this technical things. What is the switch reluctance motor, and what is the converter, and what are the things happening, and what is what type of converters are required for the switch reluctance motor, why we are going for switch reluctance motor, and I have one project. I have one research project that things I will present before you. Okay. Yes. First, I want to put some little bit introduction. In electric vehicles, they are the core element. In electric vehicles, what are the core things we know? In a vehicle, that is the IC engine is the core things. Okay. And in electric vehicles, the battery is the first that things will come after because energy will come from battery only. After that, this is like a petrol or a diesel in IC engine, and next is what that is the electric motor, and this the rapid development in the field of power electronics and control techniques. The electric motor, how that will run, we have to control. We have to what type of control? We have to means first starting, start, stop, break, and slow speed, low speed, high speed, like that. So that control things, we need some control circuit. Control means everybody knows so what are the control things, how to control, and what are the control things, what are the control parameters, everything. Okay, so we have to see what are the types of motors are required, but we cannot use all the motors everywhere. Okay, yes. In selecting of the electric vehicles, for electric drive, the electric vehicles considering the single powertrain, the following terms were considered. First is the power density, after that overload, efficiency, that is high speed range, control, noise, torque ripple, size, weight, ruggedness, maintenance, manufacturability, and cost. Okay, when we are going for electrical vehicle, what types of motors we need? With this motor, we have to see this uh, parameters. This what is that characteristics? Okay. After that, these electric motors are used in electric vehicles. What are the motors? We should know this DC series motor, brushless DC motor, permanent magnet synchronous motor, and three-phase AC induction motor, and switched reluctance motor. Okay, and we will see each motor is each motor is having their own characteristics. See. And at the end, we will see the switch reluctance motor. Why we will go for switch reluctance motor? The DC series motor, what the high starting torque capability of the DC series motor makes it suitable option for traction application. It was most widely used motor for traction application in the early of 1900s. 1900s. Okay. The advantages of this motor are easy speed control, and it can also withstand sudden increase of the load. All these characteristics make it an ideal traction motor. Okay, and the drawbacks of this motor, what is that? The high maintenance. We know the DC motor. What are the why DC motor is popular? Because of speed control. This if we are going for speed control of DC motor, that does not affect the efficiency of the motor. But if we will go for AC motor, that affects the efficiency. These things we know. Okay, and yeah, yes, and this is what again some problem where that is the commutation. And due to that commutation, what happens? The sparks are produced each and every moment there will be spark. And due to spark, you cannot run in all environments. Okay, that is not suitable for all environmental conditions. Okay, this motor comes under the category of the DC thrust motors. After that, next development of what that is the brushless DC motor. Okay, there is no brushes. Due to that brush problem, communication problem, next is the brushless DC motor. It is similar to the DC motors with permanent magnets. Okay, that rotary is a permanent magnet. It is called brushless because it does not have the commutator and brush arrangement. Okay, the commutation is done electronically in this motor because these VLDC motors are maintenance free. VLDC motors have traction characteristics like high starting torque, high efficiency, around 95 to 98%, etc. Okay, and VLDC motors are suitable for high power density design approach. And VLDC motors are most preferred motors for the electric vehicles application due to its traction characteristics. But some disadvantages is there due to but VLDC motor you can find so many papers are also there VLDC motor application to electric vehicles. After that, PMS. This motor is also similar to the same VLDC motor, which has permanent magnets on the rotor. Okay, similar to the VLDC motors, these motors also have traction characteristics like high power density and high efficiency. The difference is that PMSM has sinusoidal back EMF, whereas VLDC has trapezoidal back EMF. Permanent magnet synchronous motors are very are available for high power ratings. Okay, PMSM is the best choice for the high performance applications like cars, buses. Despite the high cost, PMSM is providing steep competition to induction motors due to the increased efficiency than the later. PMSM is also costlier than the VLDC motors. Most of the automotive manufacturers are used PMSM motors for their hybrid and electric vehicles. For example, this Toyota Prius and the Chevrolet Ford Focus electric zero motorcycles, Nissan like that, Honda, the BMW i3 like that things are for the this PMSM is used for its purpose. After that, induction motor. What is the induction motor? Induction motors, we know that three-phase induction motor. Okay, three-phase induction motor advantages, disadvantages. Everybody knows. The electrical people we know. Okay, the induction motors do not have high starting torque like DC series motor under the fixed voltage and fixed frequency operation. But these characteristics can be altered by using the various control techniques like field-oriented control FOC or VYF methods. Okay, by using these control methods, the maximum torque is made available at the starting of the motor, which is suitable for the traction application. And this squirrel cage induction motor have a long life due to the less maintenance. Induction motors can design the up to an efficiency of 92 to 95%. The drawback of induction motor is that it requires complex inverter circuit and control of the motor is difficult. Again, if you are going for controlling, that affects the efficiency. Okay, yes, this is the problem in induction motor, three-phase induction motor. Okay. After that, SRM, switch reluctance motor. We will this our topic is in that is the switch reluctance motor applicable to uh, means electrical vehicle. Okay, you can find so many papers, so many people have worked in so many directions. Please find in IEEE paper. Nowadays also the so many papers are coming out in SRM drives. Okay, so many researches going on. The SRM is an alternative to the conventional motors in the variable speed drives. First is the low material cost, like the induction motor rapid construction. Next is the high efficiency, satisfactory power to torque densities, simple control algorithm, and high speed operation. The four quadrant operation is possible. Okay, there is no need of to supply to rotor. Either you should not supply to the rotor anything and no need of magnet. Okay, and absence of magnet. Next is what adaptability to the harsh environment. These are the advantages of the SRM in switch reluctance motor. Next, this switch reluctance motor also have high power density and which are same required characteristics of electric vehicles. And since the heat is generated on the mostly on the stator, not in the rotor, so it is easier to cool the motor. Okay, rotor we are not supplying anything. That construction things I will tell. We are not supplying a rotor anything, so that rotor part is not get heated, and the cooling will be easy by only stator gets heated. And the biggest drawback of the SRM is that complexity in control and increase in the switching circuit. It is also some nice issue. Once SRM enters the commercial market, It can replace the PMSM and induction motor. Okay. You can imagine if you go for any research to get SRM is very difficult and also costly. Why? No, no, means only very little bit people are manufacturing this SRM, and you have to give the order, and then after that you will get. Again, these people will demand high money. Okay, so the SRM is because only this is for research purpose, no, not for any commercial things. So that this is costly. Okay, to find also to purchase also to get is very difficult. Okay, and again I'll tell you what is the problem. If you wanted to research purpose, we have stator pole and rotor pole. Okay, you wanted to for specific things. Again, they have to design. Okay, so that things are to get that is difficult. Next construction of SRM. Okay, yes. What is the construction? Just you see this figure. This is the SRM structure. This is the stator, and this is the rotor part. Stator and the rotor. SRM structure. Okay, and what is happening here? Okay, what is happening here? The stator is having poles, and the rotor also having poles. But stator carries winding, but rotor does not carry any winding. Okay, and here only laminated steels are there. Just you see these points. The switch returns motor is a type of motor that is doubly silent with phase coils mounted around the diametrically opposite to the stator pole. We have seen. Okay, this is the stator. This is the stator side. Stator. This is the stator part. Okay, diametrically opposite. Diametrically opposite. Diametrically opposite. After that, there are no windings or permanent magnet on the rotor. The rotor is basically a piece of laminated steel, and its step forms the silent poles. This is the rotor part is nothing. The silent pole rotors and only made of the laminated steel. Nothing is there. Okay, no winding, nothing. Not does not carry any winding. And after that, the stator has concentrated coils. The switch returns motor have simple and robust structure as they are generally suitable high speed. The several combinations of stator and rotor poles are possible. That depends upon you, means the researcher or the application. We will see what are the things if number of poles increases, stator side, rotor side, what will happen, if less, what will happen. That things also means different. You can find so many research papers based on that. Okay. Yes. The several combinations of the stator and rotor poles are possible. That is 6 by 4, 6 stator poles and 4 rotor poles, and 8 by 4, same thing, 8, that is stator poles and 4 stator poles, 10 by 60, 12 by 60, etc. Okay. And 4 by 2, 2 by 2 configuration are also possible, but with this, it is almost impossible to develop a static arc. Okay, when the stator and rotor poles are exactly aligned. Configuration with higher number of stator and rotor poles combinations of less torque ripple. Okay, if higher number of poles are there, stator side and rotor side, what will happen? The torque ripples will be less. Okay, this is the major factor of this RM. Okay, yes, how to reduce the torque ripple? There is so many papers also there, so many control techniques are there. Okay, and you can find so many papers torque ripple minimization of the SRM drive. Okay, yes. The design objectives are to minimize the core loss to have good starting capability and to eliminate the mutual coupling. Okay. Next, this is this wherever I have told there's points the same thing are here. This is the stator state. The, any motor, there is what one part is the stator, another part is the rotor. Okay, this is the stator. These windings are like this. Okay, windings are like this, and based on your stator poles and rotor poles, you have to select means the how many phases. Okay, yes, four, three phase or four phase or two phase like that. Okay. SRM structure, you see, this is the SRM structure. Okay, and this is the stator part. Inside the rotor part, this is the shaft. Okay. Now the configuration, the same thing whatever I have told you, that is depends upon the number of stator, depends upon the number of stator and rotor poles and number of phases. I have told you na, that is number of phases. Number of phases what? Number of phases. After that, the connection of the stator windings, that is the you can go for series or parallel. And the common configurations are you can find 6 by 4, 8 by 6 like that. If this is 6 by 4, 6 stator poles, you can divide it by 2 and this is what 6 by 4. This is 6 by 4. 1 minute. 6 by 4 and 6 if you divide by 3, that is 3 phases. 8 by 60, you can divide that 2, that is 4 phases. 4 phases. After that, the right motor for EV. The EV, which what is the right? Okay, for two wheeler, just 1 minute, one call is coming, 1 minute to double 2 times. Yes, please. The problem is one emergency one call 2 times call came that so I attended. Okay. See the right motor for EV for selecting the appropriate electric vehicle motors one has to first list down the requirements of the performance that the vehicle has to meet. Okay, and the operating conditions and cost associated. Okay, we cannot select any motor for that purpose, for any purpose. Okay, and okay, and the motor rating will be less than 3 kilowatt at low cost. It is better for to select the VLDC motor. For three wheelers and two wheelers, it is also good to choose VLDC motors with or without, that is external gear systems. Okay. For high power applications like performance of the two wheelers, cars, buses, truck, ideal motors, the choice could be PMSM or induction motors. Okay, once the synchronous reluctance motor and switch reluctance motor are met cost effective as PMSM or induction motors, then one can have more options of the motor types for the electrical vehicle application. Okay, cost wise is high. And another thing, the problem is the torque ripple. In SRM, the main problem is the torque ripple. Okay, and controlling things. The controlling torque ripple to minimize the torque ripple and what is that called? Your converter side. The research areas you can find First, the converter design. Okay. Second is the control techniques. Third is the motor design. Okay. Motor design. You can find several papers in SRM drive. Okay. These major requirements of electric vehicles already I have told in past introduction. I have told the high instant power and high power density. Okay, and high torque at low speed, fast torque response, high efficiency, and high reliability and robustness and reasonable cost. Okay, these are the requirements. After that, this is one converter, motor, and the controller things. Just one diagram, nothing is there. Okay, like this is a converter side, and this is the motor side. Okay, and this is the one position detector or controller. These things are, people, we have so many projects. We have seen like these things. Okay, and the requirement of the converter. To select the converter, what things you have to consider for selecting converter. So many types of the converters are there. I'll tell you next slide. I'll tell you so what are the types of the converters are there used for SRM drive. Okay, we will see the types of converter also. Okay. The requirement of the SRM converter. What are the requirement? What are the requirements? The what is that? The minimum one switch is capable to conduct three in each stage of the motor. Minimum one switch. Okay, and the converter would be capable to excite the phase before it enters the generating or demagnetizing region. Okay, and third point, demagnetization energy from the living phase must be provided back to the DC source or should be used in the incoming phase. Okay, and next is the hysteresis loss, and switching losses can be reduced by the converter. Okay, next is what, in order to decrease the voltage stress to the semiconductor switches, the converters takes to be single rail of the power source, and the less number of semiconductor switches is suitable because the switching losses will be reduced. Okay, and also cost associated with the switch will also cost saving things will be there. Efficiency of the converter is defined by the choosing the appropriate dual angle and switching strategy and control technique. This is the thing or the requirement of the SRM converter, switch reluctance motor converter. Okay. Now we'll see the types of the converter configuration. See, this is the what you can find how many you see how many types of the converters are used. How many? Okay, and you can find so many papers they have used so many types of the converters, and there is a comparison analysis. Comparison analysis is based on your what is that the torque ripple, power density, and so on and so speed. Okay, and torque like this. So many paper you can find based on this. Okay, that's the two-stage power converter. Next is the two switch per phase. That is two Q switch. That is what one is asymmetric, and variation of the asymmetric switch higher than two Q switch. Okay, and after that 1.5 switch per phase, 1.5 Q switch. Next is Q plus 1 switch. Equal sharing, C dump with freewheeling shared switch. Minimum switch with the variable DC link with the fronted back fronted buck boost converter. Buck converter, buck boost converter. After that is demand. Okay. Yes, a single switch per phase. That is the Q switch. Q switch is what? These are the R dump, bifilar, split DC, split DC supply. Q switches, that is 2Q diodes plus 2Q diodes. Yes, that is independent phase current control, dependent phase current control. Okay, you can find to go through this switch reluctance converter used in switch reluctance motor. You can find this whatever these things are presented only very less. So many converters are there, multi-level converters are there. Okay, so many converters are there. So many research is going on the converter only. So not only this much converter is used in SRM. This is only few only. Whatever I am presenting, very few. Okay. This is the R dump converter and C dump converter like this. That's just I am showing this is circuit diagram. Means the work is not done by the R dump or C dump converter. Okay. Yes. One minute. Yes. Next, that is the bifilar converter. Next will be the DC split converter. Here the voltage is divided. Suppose this is V plus minus, and the voltage is divided. The voltage is divided V by 2 and V by 2. The compactness of the converter package, the lower cost due to the minimum number of switches and diodes, capability of regeneration of the stored energy, not possible for low voltage applications. This is the what DC split converter. Okay. After that, this is the asymmetric converter. Okay. This is only few converter I have shown you. Okay. And this asymmetric converters you can find that is used for EV applications, automobiles. Okay. So many papers you can find this EV application things are um, presented in that is asymmetric converter based drive. Okay. We will see how this is the how what is the advantages and disadvantages of this asymmetric. Okay. The main advantages of this are the independent control of the upper and lower switches with greater flexibility, use of all possible firing angles, allowing the regenerative braking capability and equal performance in the both directions. The converter should work in four quadrants. Okay, one is motoring mode, regenerative mode, again reverse things, braking. Okay, like that. So the because what is the thing? Suppose we are driving the vehicle that forward and reverse again sudden stop, sudden start. These things are there. So we should operate the motor in four quadrants. The main disadvantages are the high number of power devices per phase and the possible problem of low voltage applications having the two forward voltage drops, the relatively low demagnetization voltage at high speeds due to the fixed voltage supply, the need for the large capacitor on the supply voltage to filter the voltage ripple, and the fact that the demonetization during the generator operation mode with large currents will the significant power loss to the diodes. Okay, this topology is one of the most used with applications in many fields such as automobile and the aerospace industries, okay, and renewable energy sources. Okay, this is the thing, and our work is based on the asymmetrical this converter, asymmetric converter. Now this is I'm operation just I'm showing how this is operated. Okay, how phase A is excited, B is excited, and C is excited by this converter. Okay, how A phase, B phase, and C phase, D phase are excited. First, you see, this one switch is on, the current will flow like this. This phase A is getting excited. The, this position alignment, you can find it here, the rotor pole and the stator pole at A position, at A point, A phase, you can find at this point. Next slide, you see, that is the affected when A is up, A switch is up, A phase is up. What happens? B phase we are triggering, we are giving the triggering pulses to the B switches like this. T1, T2. Firing angle with firing pulses we have given T1 and T2 so that this winding will get energized. When this winding is energized, the uh, the rotor pole will be attracted towards this pole, this pole. Okay, where is the low reluctance path, low value of reluctance, the rotor will be attracted towards that only. Okay, so when T1 and T2 is energized, T1, T2 is switched on, or you are giving firing pulse. What will happen? The current will flow through the T1 and the T2, and the A phase gets energized. Okay, when A phase is getting energized, the rotor pole will be attracted to F phase, towards F phase. Okay, and D1, D2 are the freewheeling diodes. Whatever the energy is stored, that will be distributed. Okay, or that will freewheel so that the device will not get damaged. Okay, like that, and the energy will come back to the source. Okay, this is the first phase. Second phase. How the second phase? You remove these pulses to the T1 and T2, give the firing pulse to the T3 and T4. If you give the firing pulse to the T3 and T4, what will happen? Next phase will be energized. When next phase will get energized, you see the B is the B phase, your rotor is aligned with the B phase. Okay, the rotor is moving. This the same rotor pole moves towards the B phase. Okay, and similarly, C phase, we are removing these pulses. We are okay on. We are making up this thing. When we will give the up, when we will twist up, or we will give the means what is that called? We will off this thing. What will happen? Now we have to on this phase C. If we will give the pulse firing pulse to the C phase gets energized, and the rotor is aligned with the stator pole. C pole. Okay, and next pulses we have to give to this is a four phase motor. This is not a three phase. Okay, this is a four phase motor. You see one, two, three, four, five, six, seven, 8. So that we can easily divide it four phase one is not, another is south, north pole, south pole, north pole, south pole. Like that. Pair of the poles. This is the four phase. Okay. Next will be what I have given energized this D phase. If you are giving you are energizing or giving the carrying pulses to the D phase switches, photonic switches, either transistor or IGBT or whatever may be, that phase will be on, that phase will be energized, and the rotor will be pulled, will be attracted towards that phase. The rotor pole will get attracted to that towards that stator pole. Okay, like this, the motor will rotate, and the thing is what we have to design the circuit. Okay, and we have to design the first circuit. Again, we have to get the firing pulses like this. First phase, next second phase, next third phase, next fourth phase. Again, you have to come back to first phase, second phase, third phase, fourth phase, like that, so that your rotor will rotate, and one completely uh, rotation you can find. Okay, after that, accordingly you give set the time, other things, and the rotor will rotate continuously. Okay, so the designer, he has to do all the things. Okay, yes. We should have idea how to give the pulses to first phase, next second phase, next third phase, next fourth. Okay, if this is a three phase motor, like that, first phase, second phase, and third phase. Okay, and so many research is going on, so many values they got, so many data are there. Okay, and if you are going this way, one problem is there. If you are going that way, another problem is there. You can find, if you read several papers, you can find what are the merits and demerits of even converter also. Okay, even converter also, you are the same signals motor you are operating with this converter, that converter. So many merits and demerits also there. Okay, so you should have thorough knowledge about the converter, a thorough literature review about this converter before doing any research. Okay, otherwise we have to waste the time. Okay. The objective, the control of the speed of the switch reluctance motor. This is what the project. Okay, these things whatever I have explained, these are the basic things. Okay, what is for electric vehicle, and what are the things we have means the basic things only. What are the motors are used for electric vehicles? Why SRM, and SRM, what are the requirements? Okay, again, if you go through this already you are teacher, you know special electrical machine, one SRM, one unit is there, that will take 10 hours. Okay, and so many things are there. You have to teach so many converters, converter operations. Again, you have to teach the constructional part in details. Okay, again you have to speed your torque and torque speed characteristics. Okay, again so many things are there. You know, I think you know well. Okay, this is not a one small thing. See, in 1 hour everything will be over. Okay, and this is only basic things, what to do. Okay, yes, and one minute. Yes, this is what the operation. This is operation whatever I have explained to you. Okay, and this is the one project. Project means funded project. I have this is the one ME student, he has done this project. The funded project 1 lakh rupees funded project. The problem is what we are testing for only SRM, the speed things. Speed control is possible or not. Okay, starting, braking, and reverse things, that things are pending. Okay, and how to write the program and generate the pulses for the reverse means you have to do proper things. It means you have to start. You have to run the motor at different speed. Again, if you are applying brake, what is happening? Okay, again, you want stop and operate in a reverse mode. Okay, yes, sir. Again, you have to do one thing. You have to see the torque refill whether this is possible or not to run the vehicle. Okay, so many things are there. This is only some experiment we have done. Just I am presenting. Okay, to control the speed of the speed reluctance motor drive at different speeds without with and without load conditions. We have seen if any sudden increase of load, what will happen? If that vehicle will not able to carry the people, that is also another problem. Okay, you know this buses, how much bus train means what is the number of seats, but the people are traveling multiplied by 2 or 3. Suppose 70 seats are there, you can find, and this multiplied by 2 or 3 times people are traveling. Okay, so you have to see that things also. Okay, and everything, if you are totally continuously working on that, then only you will get so many things. Otherwise, simply one experiment that will not give the correct result. Okay. And this is what we have used to here simulation work, and after that this hardware work by using the DSP processor. Okay, and here this H bridge used to, that is asymmetric. Asymmetric bridge, asymmetric converter is used. First point, and another thing we have simulated by using the that is PI controller and PID controller. Next also we have tested. I am not. I have no data because I am not in college. Okay, in college in my system these things are there, and also we have simulated this MATLAB PID also in fuzzy logic controller. Fuzzy Neuro also we have done that work. And another thing I want to say that ANSYS we have also analyzed this power things, that magnetic characteristics of different poles. Okay, are different of different materials of the SRM drive. Okay, we have done some work also. We have done to test this magnetic characteristics. Okay, which material is suitable for the thing, that things. Yes, that things I am not going to present here. Just small things I want to present there. Yes, you see, this is one IEEE paper. Okay, this is an asymmetric converter, and here this is the controllers. Okay, this is the controllers. This is the what the SRM windings. 1, 2, 3, 4. You see, work is done by using 8 by 6 poles. Okay, 8 by 6 poles, and this is what an asymmetric uh, bridge converter. You know, our supply is the AC. We have to convert to DC. We have not used battery. Okay, so this left side, this side is nothing. That is one AC to DC converter. Okay, direct bridge converter, and after that, this is AC to DC converter. Next is the this DC is here capacitor is there. After that, this is asymmetric converter. This converter. This is what the MATLAB the simulating diagram. Okay, this is the simulating diagram by using the PPID control, and uh, another work is there for fuzzy and neuro control. Okay, and after this, after getting this result, we have tested in hardware. Okay, yes, this is SRM. Here, this is these things, your scope, and after that, this is a controller. Okay, these things are controller like this. Okay, after that, this is your simulation things. Speed, how that speed, the starting position, you know, starting position that will start from zero and will reach at maximum. After that, slowly, this is one peak overshoot. Okay, this is the peak overshoot. After that, this settled. After that, breaking. This is the breaking. And this is the PID controller. The same thing. See, this thing is overshoot to after that, sometimes that is settled. Next is what this is building. This is starting running. After that, you are applying brake, which with the PID load control with load and without load means suppose this motor is running and catches the speed here, whether this controller is working or not. Okay, whether this controller is working or not. How you will see? You put some disturbance. Okay, if the motor is at load, you remove the load. Okay, if the motor is at load, you remove the load and see the characteristics. Your peak overshoot, steady state response, like that things that things you find. Suppose the motor is running without load, just you put load. If you put a sudden some load, what will happen? The speed will be reduced, and after some time, that will catch the required speed. Okay. After that, this is the hardware things. Hardware things what we have DSP processor. Okay, this one is the DSP processor. This one, DSP processor. This is the drive circuit. Okay, this is the drive circuit. This is auto transformer, and here we have DSP processor. We have written the program, and based on the program, you have to run. You have to generate the firing pulses. Okay, and after that, this program will be dumped to the DSP, and based on that program, uh, that one in DSP processor, not only processor that is on board. Okay, there is so many things are there, and you have to dump your program or everything to there. After that, you have to run. Okay, and this ribbon you are seeing now, ribbon this one, this will generate the firing pulses. Okay, and after that, this will go to your converter circuit, and the converter circuit is connected to here. See, this is the SRM. Okay, 8 by 6, 4 plates, 8 by 6 SRM. Okay, and this is the requirement things, and this is your DSP processor up to 8T5, the processor name. This is the DSP processor, and this is the associated things. This is the DSP board. After that, this is the SRM motor. Okay, this is only 0.5 HP. Okay, 0.5 HP that was not available. By contacting so many people, after that I gave order. The people have constructed and they sold. Okay, if you go market, you will not get a switch reluctance motor. If you go for any company like that, companies, I don't want to tell the name. they will put more. They will tell you take a converter and this converter is fixed with this. What is that motor? If you take all the things, we cannot give you this motor separately. Again, if you ask the motor, the same motor they will ask 50,000 rupees. Okay, like that. Difficulties are there like this. After that, I have told you, no, this things the same thing here, and what is that? The complete board, driver circuit, and buffer circuit, this power section, over current protection, current sensors, this capacitor, this filter like that, so on and so. Okay, and after that is separate things. Whatever the board, same thing, separately, one, separately is one. Okay, this is the driver circuit. Everybody knows. Okay, after that PWM. Our main thing is PWM. How to operate the motor. Okay, this is the PWM outputs. Okay, these are the PWM pulses of different switches. Same thing, position sensor output here, and after that we can find out how much RPM to 2155 RPM. Okay, duty cycle receive to 70% like that. So these are the current ripples. Okay, current ripples means you can get torque ripples. Same thing, this is pulses only, pulses only. Repeated, okay. This is repeated, okay. This is current sensor output. Okay, after that conclusion. These are the references. Okay, conclusion what we have discussed all the things about this. What are the electric vehicle applications for different motors and which is suitable, and about switch reluctance motor, how that operates, and what are the types of the converters, and the one project I have explained how this project we have done, and this we have not minimized these ripples. This ripple was high. Okay, we are going to work on how to minimize the ripple. Okay, these are the what the reference papers. This is the reference papers, and some I have collected these diagrams and some points from books, from internet, and my own project. Okay, thanks to all. And if you have any any question, please ask. And if I know, I will answer. Otherwise, I will mail to you if I don't know. Please.
Yes, thank you, sir. Participants, right now, if you have any queries, you can unmute yourself. Yes,
If
participants that we.
please ask the question. If I know, I will tell. If I don't know, I will mail to you the answer. Okay, after finding this, and also you know well who knows who is working on that, he knows more. Okay, what are the limitations of the things? I will ask my students what worked. I have worked, but the student knows more. Why? Because they have completely involved all the things. Okay,
Yes, sir, sure,
if
sir.
any question,
Participants, yeah, yes,
Uh,
participants, yes, sir. Come on, sir.
yes, good afternoon. This is Dr. Mahesh from Bangalore. Sir,
okay, please.
yes, sir, Nilkana, sir, which, as we are in the topic of electric vehicle, so what will be your preferences in terms of BLDC with reluctance motor?
Say that is actually if you ask any industry people, they will tell you induction motors we are using for electrical vehicles. Okay, if you go for assembly land or any port like that, you can find this answer. But the
Okay.
thing is, this is the research things. We are not this switch reluctance motor you cannot find anywhere used for electric vehicles. Some things are satisfying, so that this is research, we are doing research on whether this is applicable or not. Okay,
Okay.
if you
Okay.
go for any company, they will tell only induction motor we are using. Okay,
Okay.
because this is very simple, simple to control and do all the things in induction motor. Here the problem is torque ripple and cost also. Okay,
Okay, sir. Okay.
this is
So
only research we are doing, finding things.
So with differences with BLDC and with SRM, sir, anything from your end which you can distinguish between those both?
That things already I have explained. I am showing this PPT, this BLDC. BLDC is for right choice for small vehicles. Whatever
Correct.
the literature survey I have collected, this
Okay.
BLDC things, you see, I have that's why I have explained all the things in BLDC.
Correct.
This is series motor and brushless DC motor. Already I have explained you all the things. BLDC
No.
motor.
Yes, sir. We
Okay.
were just. My question was, which will be more advantageous? I mean, as you say, this it is be depending upon the small vehicle, big vehicle. That's what you try to say.
Ah, yes, yes, right. Whatever your question, right. Thing is whatever the motor based on your so many things are there. Okay, this is for small vehicles. You can go for BLDC. For
Okay, sir.
more getting motors, more getting things, more load, you have to go for your our induction motor. Okay,
Okay, sir.
and
Fine, fine.
the induction motor and this the SRM motor maximum similarities are there, but the
Okay.
problem is what here torque ripple is there. That is the problem. Again, control also. That will be also another problem. Okay, that
Okay, sir.
induction motor everybody knows VFD drive. Okay, DYF drive.
Correct.
Very good. Yes, that is popular. Okay, so that is simple. Everything is simple for induction motor.
Okay. So you mean to say that basically what we have worked on, you worked on is for the research purpose.
This is only for research purpose. This is
Okay,
not
sir.
for, we have not run any more, not run any vehicle. Okay.
Okay, sir. Fine, fine, fine,
Yes.
fine, fine. Right, sir. Thank you
Okay.
very much, sir. Yes,
Okay.
thank you.
Thanks. Sir.
Yes, any other participants? If you have any queries, you can raise your queries. Yes, okay, sir. Thank you, sir. Okay, sir. Thank you very much, sir. On behalf of
Okay.
Panimalar Institute of Technology and Deputy Department, I once again thank you, sir, for your valuable speech. That you have been given a lot of information based upon different kinds of motors and what kind of motors that we need to specifically use in small electrical vehicles and big electrical vehicles. And once
Okay.
again, thank you, sir. Thank you very much, sir.
Okay, sir. Thanks. You have given
Okay.
opportunity to present before the audience, and you have given opportunity to participate or present in your FTT program. Okay. Thanks, sir. And thanks
Yes,
to
sir.
the
Yes, sir.
management. Thanks.
Thank you, sir. Always you are welcome, sir. Thank you, sir. And
Thanks.
participants, okay, thank you, sir.
Thank you.
Participants, your feedback form will be posted in the chat box. You can fill the feedback form. Right. As participants, the feedback one has posted in the chat box. Kindly fill the feedback forms.